Okay, in this video I want to talk about relative dating and index fossils. So what's relative dating? Okay, basically a technique that compares the age of one fossil or one rock with another to determine which is older. Determine which is older. Okay, basically relies on two different facts. Number one, sedimentary rocks form in layers. Number two, fossils are the same age as the rocks in which they formed. Okay, that's pretty self-explanatory. Now, sedimentary rocks, a sedimentary rock forms in layers, okay? And this is known as something called strata. So sedimentary rock forms in layers. That's known as strata. Okay, a single layer is called a stratum. Okay, so strata is a plural. So different layers, that's a strata. One layer is called a stratum. Okay, now sediment always settles, and so the one at the bottom, so different layers, let's say, the layer at the bottom is the oldest. Okay, the oldest stratum is at the bottom. At the bottom, right? Makes sense because over time, more and more layers pile up. And the newest sediment at the top here, right? The outermost layer. Now that gives a way of determining which organisms lived earlier than others, okay? And fossils from the bottom layers of the rock should be the oldest, right? So it gives way of determining which organisms lived earlier than others. Okay, using this technique. Now, sometimes this is, that law, there's a law actually called the Law of Superposition. Okay, it's usually called the Law of Superposition, the fact that the lowest sediment is the oldest and the highest one is the newest. Okay, Law of Superposition. Now, sometimes the lowest stratum, I should mention, is not always the oldest. Okay, so sometimes the lowest stratum isn't the oldest. Okay, because layers of rock have folded over each other and have been turned upside down by movements in the earth, okay? So why? Because of Earth's crust movement. Okay, so layers can fold on top of each other, Earth can move up and down, yeah? So that's that. Let me now talk about index fossils. Now, fossils that can be used to compare the ages of strata in different locations are called index fossils, okay? These are fossils that can be used to compare ages of strata, okay, different layers in different locations. Okay, index fossils. And to be used as index fossils, the species must, okay, they must satisfy these four criteria. Number one, they should have been fairly widespread, so existed in different locations, so fairly widespread when they were alive. Number two, they have lived in fairly narrow period of time. Okay, it could be 1 million years, could be 2 million years, maybe even less. Don't really know the technicalities. It varies. Number three, they should have been abundant. Okay, so lots of them should have existed everywhere. And number four, they should have been easy to identify, okay, in terms of fossils. So index fossils basically allow rock layers in different locations to be compared and dated. Okay, and so index fossils can thus be used to date rock layers. So index fossils allow rock layers in different locations to be compared and studied, compared and dated. Okay, they can then be used to date rock layers. We're going to talk about a special type of index fossil that's commonly used. They're called trilobites. So index fossil example. I'm sure you've seen these things in popular culture. Trilobites. Okay. There are many types of different index fossil that exist. There are two really good ones, including trilobites. Okay. They're now extinct. Okay, but they're classified as anthropods, okay, because of their external skeleton, the way they look. They're called anthropods. Okay, and anthropods, okay, anthropods basically include crabs as well. So crustaceans, crabs, spiders, okay, and trilobites. And here's what they sort of look like. Excuse my drawing, it's a bit bad. Basically got a head here, it's got antennae. Two antennas, okay, and it's got really fine legs everywhere. It sort of looks a bit like a fat caterpillar. Okay, these are its legs. Okay, they're good index fossils because, so here's why they were good. Good index fossils because, and as I talked about on the previous page, the good index fossils have to be abundant. Remember, stuff like that, because they were quite common back then. Widespread, so they were almost all over the planet, and different species existed at different times. Okay, so they were abundant, pretty much. That's trilobites.